Hey, hi guys, here's a quick rough and ready video that I'm just going to unbox a product that's just had to go and collect from the post office. So we've got this parcel. It came to me all the way from Australia. So I think we should just gently open this one up and see what's in it. If you're into electronics in any way, you probably have a clue as to where this has come from. But we shall see when we open it. See how quickly you recognise the contents. So there's the box itself. It's a plain, mysterious box at the moment. I'll just open this one up and see what is contained. So these little flaps are always a little bit difficult to get access to sometimes. There we go. Okay, so that's that opened there. And we'll pull out a set of multimeter leads, and we also have a couple of clips, and we have a Keytech thermocouple in there. And we have the main item itself, which is the EEVBlog BM235 multimeter. I've been following Dave's channel for probably a couple of years now. I think I've watched all of his videos, and when he recently released this, I simply had to get my hands on one as a little bit of a payback to thank Dave for his work, and because my old multimeter, well, it's old and it's had better days. Ooh, there's batteries inside. So just to give you an idea of my old multimeter, let me just go find it. So here's the old multimeter that I've been using for quite some time, let's just say. I think this Rapid Electronics 360 DMM, this one, has been with me, battery low warning, it's been with me for in excess of 20 years, I think. 9-volt battery in the back there, does well. Capacitance, inductance, impedance, frequency, TTL, audio triggering, all sorts. Quite a decent meter. I mean, I've really enjoyed it for a long time. Recently had to re-lubricate the switch because it was just getting crazy, so some silicone oil under there to loosen that off again. Not sure how it's doing calibration wise. That's going to be one of the things I'm going to test in a few seconds. I'm going to test it versus the EEVBlog one and see how it performs. So I think I'll just stop the video just now. I'll grab some multimeters, I'll get my little calibration test circuit out and see how it proceeds. Back in a moment. Okay, and we're back. So we have here now my little test circuit that I built up a long time ago. This is basically, don't know if you're going to be able to focus on, see that there. This is a voltage reference. It's a PIX002 BP, Bravo Papa, and some 9.01k resistors. I think they're 0.1%. I really can't read that there. Anyway, so 9.01, so there's 5 of them in series, and they go from 5 to ground. So it gives me a 5, 4, 3, 2, 1 voltage, and it also gives me current on the lower 4. So it gives me lots of microamp ranges. Just fed from a 9-volt power supply. Literally just built this up not that long ago. It's very basic, but you know what? It performs and it does what's actually needed of it. So let's do a quick test on this. So we'll put power on the little circuit there. I'll give it a few seconds to warm up. We'll grab the old multimeter leads and we'll plug those in. We'll go to the 4 volt range on this meter, and we'll just go from ground to the 4-volt pin. Let's actually do ground to the 4-volt pin, please. Thank you very much. So ground to the 4-volt pin. So the old meter is reading 3.997. Well, we'll call it 3.996. Again, it is showing a battery warning, so don't know how close that actually is at the moment, but I didn't bother replacing the battery because I knew this meter wasn't going to be far away, the replacement. So we'll take out the new leads. They feel really nice actually, lovely silicone sort of feel on them. And we'll connect the new leads up to the volts, ohms, amps range. We'll switch the meter on for the first sort of time, other than a moment ago. So it's on DC voltage. I'll just short the two leads together, and it's reading 00000. That's pretty much what you would expect. So let's do that same test from 0 to 4 volts, or 5, or 4 volts we'll go to. So 3995, 3996. Let's go to the higher one, 4996, 4997. So we're what, 3 millivolts out on what theoretically is a 5-volt reference. So it seems to be accurate here. So let's just start at the bottom there. So we've got, as it settles in, so the 1 volt through the divider is 998, 1997, 2996. So we'll do the same on the old meter again, just for 1 wee second, to see how the calibration of this thing's holding up after 20 years. So we've got 999, 1999 instead of 2 volts, 2998 instead of 3 volts, and 399. I'm going to call that 6 instead of 4 volts. So it's very good. I'm just going to flip this into current reading and put it on my milliamps range. In fact, yeah, so we'll go from ground to the 4-volt feed. So this will be the highest current feed reading. So it's reading 1.65 milliamps. Again, that's the 5 volts through the that's 5 volts through the 9k resistor. So 1.65 on this one. Okay, I'm a little confused by this here. We need to work out what's going on. I don't know if I'm making any silly mistakes here. So we'll go from the bottom resistor. Oh, of course we're making a silly mistake. We never moved our lead. What are we like? I was measuring the voltage there, but in the current E-type range. Don't honestly know what that was reading. Anyway, let's try that again. So we'll go back to the milliamps. We'll do ground to that one. So 1.65 milliamps. The same as the other meter was reading. So we'll go down to the bottom range just now. So this is the 1 volt output effectively through this resistor chain. So 291.4 microamps. So 291.4. And on this one here, so that's measuring 400 microamps. So that's an interesting variation there. So I've got 400 microamps there. And on this one, we have 291. So let's just go to the top one again, the 4 volt feed. Need to change range. So 1.6 mil. So they're pretty much the same, especially if you go into that range there where you're losing a wee bit on the accuracy, 1.65 milliamps. So that's fine. We'll step down to the 3 volt feed now. On the 3 volt feed we're reading 0.82 of a milliamp. And on the new meter we're reading 0.82 of a milliamp. So they're very close at that sort of range. We'll go down to the 2 volt feed now. We're reading 0.55 milliamps. And we'll go down to the 2 volt feed on the other meter. A bit slower in settling, but exactly the same. So let's do the final one, the 1 volt one. So we're reading 0.41 milliamps on that range. And on the other meter we're reading 0.41 milliamps as well. So I wonder if it's a ranging issue. Let's just go down to that. It's going to be over scale, but we'll see how it measures. Could be calibration, it's just a wee bit out. Yeah, so it looks like the last range, I mean this old meter, it looks like the microamps range has just gone crazy. So we've got 0.41 milliamps, and if I go down to the microamps, 291. So it looks like the microamps range has gone wrong on that old meter. So let's just stay with the new one again for a second. We'll go between the milliamps range. So we've got 0.4, 0.41, okay. So if we come down here, we should have 400 and whatever. So yeah, I mean, I think they're both just a little bit drifty on that last setting there. So yeah, very good. There's the input error warning because I'm still plugged in to the milliamps range. Right, so nice feature that stops you accidentally shorting out voltages. So I'm just going to measure the excuse me, the 4 volt feed again. So 3996, and I'm going to put it into low impedance mode just to see what happens here. And it loses range there, I think, doesn't it? So I don't know if I can auto scale or scale this one in any way. I don't think it lets me do any scaling there. So that's a little bit of a nuisance, but okay. So there's an initial test on this meter, the BM235 from EEVBlog. I actually like it. Just as a quick comparison from one to the other, it seems initially to be very good. The bail stand, yeah, it does feel a bit on the flimsy-ish side, but then this one broke off after a handful of years, so I'll just be careful with it. But yeah, this is, it seems nice. It's a lovely size. It's got a good feel about it, this meter. The case is pretty robust, and the rubberized case is very good. I used to have one for this, but lost it a long time ago. So yeah, I'm liking what I'm seeing. I'll probably be using this going forward now, although it's good to see that this old meter is still pretty much calibrated. So I'm really happy with that. This will be my new daily go-to. So thanks very much for watching. If you want to see more videos on all of this, I'll show a wee circuit diagram of this and some calibration points as well separately. But thanks very much for watching. Remember to subscribe and come back and watch some more videos soon. Thanks very much for your time. You have a good day. Bye-bye.